Exponential functions. Exponential functions are any functions whose equations contain a variable in the exponent. Exponential functions are defined by f of x equals b to the x power or y equals b to the x power. This is different than the functions that we have been dealing with. The functions that we have been dealing with look like this. F of x equals x squared, where our variable is the base. In exponential functions, the variable is in the exponent. The exponential function f of x equals 42 2/10 times 1 56/100 to the x power models the average amount spent f of x in dollars at a shopping mall after x hours. Find the average amount spent to the nearest dollar after 3 hours at a shopping mall. Well, this tells us that the x in the function represents the number of hours at a shopping mall. They want us to find the average amount spent to the nearest dollar after 3 hours. So all we need to do is replace the x in the function with 3. I'm going to show you how to use a calculator, or the calculators that I have specified that I want you to use in this class. I had stated in the syllabus that you need to have either a TI-36 XPro or a TI-30 XIIS. For the TI-36 XPro, which is the calculator that looks like this, we type in our function from left to right. So we have 42.2, and then open the parentheses, so we just use the parenthesis buttons on the calculator, parenthesis 1.56, and we close the parenthesis. Now we need to raise it to the third power. Well, if you'll notice, this button to the left, this one right here, has an X, and it's got a little square as the exponent. So that's going to put our cursor up in the exponent. All right, and then we just type in a 3 because we're raising it to the third power, and then hit enter. And it shows us that after 3 hours at a shopping mall, the average amount spent is $160.21. But it says to round it to the nearest dollar, so it would be $160. Now we're going to do the same thing with the TI-30 XIIS. All right, so we type in 42.2, then we open our parentheses, 1.56, close your parenthesis, and then to raise a number to a power on this calculator, we use what's called the caret key. So the caret key looks like an arrow pointing up, and it's this little key right here. So we press that key, and then that raises our number to a power, and we're going to raise it to the third power and hit enter. And we get the same answer, $160. So the average amount spent at a shopping mall after 3 hours is $160. Now we're going to look at the graph of an exponential function. To graph any type of function, we can create a t-table, and I've written out a t-table here. Of course, in a t-table, you can choose whatever points you want to plug in for x. I want to see what the graph is doing on both sides of the y-axis. So I'm starting at -2, and I'm going to plug in -2, -1, 0, 1, and 2. So if I plug those points into my function for x, I have 3 to the -2 power. Well, if you'll remember, to get rid of a negative exponent, we flip our base. So if I flip my base, I'm going to get 1/3 squared, which would be 1/9. All right, and then if I raise 3 to the -1 power, that flips my base, and I get 1/3 to the 1 power, which is just 1/3. If you'll remember, anything raised to the 0 power is 1. Then, of course, 3 raised to the 1 power would just be 3. And 3 squared would give us 9. Now I'm going to plot those points. -2, 1/9. -1, 1/3. 0, 1. 1, 3, and 2, 9. All right, so this is what the graph of this function looks like. Let's look at another one. Here we have f of x is equal to 1/3 to the x power. I'm going to use the same points to plug in for my x values. And if I have 1/3 to the negative 2 power, remember to get rid of the negative, we flip the base. Well, if I flip 1/3, I get 3. And that would be 3 squared, which is 9. 1/3 to the negative 1 power. If I flip it, I just get 3 to the 1 power, which is 3. We just said anything to the 0 power is 1. 1/3 to the 1 power would be 1/3. And 1/3 squared would be 1/9. Alright, so if I plot those points, -2, 9 would be up here. -1, 3. 0, 1. 1, 1/3. And 2, 1/9. Oh, I didn't go through that point. Alright, so that's what this exponential function would look like. So if you'll notice the difference between these functions, this is a fraction, 1/3 raised to the x power. This was a whole number, 3 raised to the x power. The whole number exponential function rises from left to right. The fraction exponential function falls from left to right. In both of these exponential functions, the domain is from negative infinity to positive infinity. Both of these go from negative to positive infinity. But both of them stop, they don't cross that x-axis. So the range would be from 0, 0 not being included, to infinity. Both of them also cross through this point, 0, 1. So all exponential functions that don't have shifts, anything added to it or something like that, then they would cross through this point, 0, 1. Now, exponential functions are functions that are used in all different types of applications. We use exponential functions when we're talking about population growth, when we talk about bacteria, viruses. We also use exponential functions when we're dealing with interest. And one number that is used in lots of exponential functions is the number e. And you may think, well, e is a letter, not a number. But in math, e is a number. It's an irrational number, just like pi is, because it doesn't stop and it doesn't repeat. So these are the first several digits of e, but it keeps going and doesn't stop and it doesn't repeat. So that's why this says e is approximately 2.718281827. But this number is very useful when we are trying to evaluate exponential functions. The exponential function f of x is equal to 1066 e to the 0.42x power models the gray wolf population of the western Great Lakes, f of x years after 1978. If the trend continues, project the gray wolf's population in the recovery area in 2012. So x in this function is the number of years after 1978. So the way that we figure out what x is in the function is we just subtract 1978 from 2012. If we do that, we get 34. So this is what we would put in our calculator. 1066 e to the 42 times 34 power. All right, so let me show you how to do that in the two different calculators. All right, so we're going to put in 1066. And then the E button, if you'll notice, is right here. It's got E and it's got a little square, meaning that it's going to raise it to a power. So we do that, and that automatically puts in E raised to a power. So we just have to put in what power we need to raise it to. So we're going to put in 0.42 times 34. So we could either do times 34 like that, or if you want to put it in parentheses, you could put it in parentheses. Times 34. Either way, it's going to calculate it correctly. And then we hit enter, and we get 1,696,220,885. That's a lot of wolves. All right, so now let's look at it in the other calculator. All right, so in the TI-36 XIIS, Again, we just type in 1066. Now the E button here is not on the actual button. If you'll notice on the LN key, the natural log key, above it, there's an E to the X power in blue. So to get to that, you press the second button and then press the LN button, and that gets you to E to a power. All right, so if you'll notice, it typed in E and it already did the caret key, which means it's raising it to a power. So then we're going to put in 0.42 times 34, and then close our parentheses and hit enter, and we get the same amount that we did earlier. Okay, so now we're going to talk about interest. Interest is also we use exponential functions when dealing with interest. Compound interest is interest that's computed on an original investment as well as on any accumulated interest. Principal is the amount that's invested, so if we're going to deposit some money in an account, that's the initial amount that we deposit, or if we borrow an amount, say on a credit card or something like that, or for a loan, the original amount is the principal. Our interest can be compounded at different increments. It can be compounded semi-annually, which would mean twice a year. The compounding period is every 6 months. It could be compounded quarterly. This is 4 times a year, and the compounding period would be every 3 months. Or it could be compounded continuously, where the number of compounding periods increases infinitely. Some that are not listed here are monthly. Of course, that would be 12 times a year, every month. Daily, that would be 365 times a year. So there are a number of different possibilities when we're talking about compoundings. The formula for compound interest uses these variables. T is the number of years that the account has gone on. The balance in the account is A. P stands for the principal amount, and we talked about that. The interest rate is represented by the letter R, and it needs to be in decimal form. So if they give you the interest rate in percent, it needs to be changed to a decimal. And these are the formulas that are used when we're compounding interest. For n compoundings per year, which means a number of compoundings per year, the formula that we use is A is equal to P times 1 plus N over R raised to the NT power. And for continuous compounding, we use what's called the PERT formula. A is equal to P times E raised to the RT power. All right, so let's figure out some interest. A sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years subject to, and the first one is quarterly compounding. All right, so let's write out I'm going to write out the formula so we can follow it. Okay, so A is going to stay A because that's what we're looking for. We want to know what the amount in the account is after we compute the compounding. But P, the amount that we start with, our principal, is $10,000 times 1 plus, all right, R is our interest rate. Well, our interest rate is 8%, and remember we need to change that to a decimal. So we would change that to 0.08. And then N is the number of times per year. Well, we're doing quarterly compounding, so the number of times per year would be 4 times a year. And then it's raised to the N times T power. So N again is 4, and then T in this case would be 5 because it's for 5 years. So you could either leave it as 4 times 5, or you could multiply that out and raise it to the 20th power. Okay, so let's put that in the calculator. All right, so we're starting with $10,000, and then we open our parentheses, and it's 1 plus, okay, so then we have a fraction. we have 8 hundredths divided by 4. So there's a key on this TI-36 XPro where we can put in a fraction. So this right here that looks like a fraction with the little squares, we press that button, and that puts us in the numerator of our fraction. So I'm going to put in 0.08. And then we use this right here to scroll down to get down to the bottom of our fraction. And I'm going to put in 4. And then we use this scroller again to get out of the fraction. And then we close our parenthesis. Okay, so then all of that needs to be raised to a power. Okay, so remember, to raise something to a power, we use this key here where it's x and it's got the little square for the exponent. That puts it up in the exponent. And I can either press 4 times 5, or I could just put in 20 because 4 times 5 is 20, either way. And then I hit enter. Oh, I didn't hit enter. Here's enter. And I get $14,859.47. Okay, so we're dealing with money, so we always want to round to the hundredths place if we're dealing with money, because that's how we deal with money. Okay, so now I'm going to show you what it looks like in the TI-30 XIIS. Again, we put in 10,000. Then we open our parentheses, 1 plus, okay, so we don't have a fraction key in this calculator, so we just have to put it in with the division bar. So it's going to be 0.08 divided by 4. And then we close our parentheses. And then remember, the way that we raise something to a power in this calculator is we use the caret key. So I'm going to press the caret key, but then if I put in 2 separate numbers like 4 times 5, I need to put that in parentheses just so my calculator doesn't raise it to the 4th power and then multiply the whole thing times 5. So you can either raise it to the 20th power, or if you're going to put in 2 separate numbers, go ahead and put it in parentheses, 4 times 5, and then close your parenthesis. And then hit enter, and we get $14,859.47. Now, to compound monthly, everything in the equation would be the same except for our ends. So every place that we have in our quarterly compounding equation, every place that we have an n, where we have a 4, we're going to replace that with, since it's monthly, that would be 12. So it would be 10,000 times 1 plus 8 hundredths divided by 12, raised to the 12 times 5 power, or you could just raise it to the 60th power. Okay, so if we put that in our calculator, we get $14,898.46. Now, for continuous compounding, we don't use the same formula. We use that PERT formula, which is A is equal to P times E to the RT power. So in this case, again, we're looking for A. RP is 10,000. We have the number E, and that's raised to the R times T power. Okay, so again, R is our rate, and we have to change that to a decimal, so 0.08 times T, which is the time, so it's 5 years. So we're going to multiply that times 5. Okay, so let's look and see how we put that in the calculator. Alright, so we have 10,000, and then remember we use this E button, E, and it's got the little square for the exponent, so it's E raised to a power. So we're up there in the exponent, and we're just going to put in 0.08 times 5, and hit enter, and we get $14,918.25. And then for the TI-30 XIIS, again, we put in the principal, which is $10,000. And then remember, our E is that it's not on the button, so we have to press second and then press the LN button to get to the E. And that raises it to a power. Okay, and then it's already opened up a set of parentheses, so we're going to put 0.08 times 5 and close our parenthesis. and we get $14,918.25. So if you look at the different amounts that we got when it was compounded quarterly, we got $14,859.47. When it was compounded monthly, it was $14,898.46. And when it was compounded continuously, it was $14,918.25. So the amounts are close, but the more number of times that it's compounded, the more it is. So if you wanted to invest some money, you would want the compoundings to happen more frequently. And if you were borrowing money, if you had, if you were getting a credit card or taking out a loan, then you would want it to be compounded less frequently, because the more number of compoundings, the higher the costs. But if you are doing any type of an exercise where you're trying to find the compounding amounts, just notice the amounts should be close to each other. So if it jumps from $14,859 quarterly, and then you try to figure it monthly and it jumps up to $20,000 and something, then you probably did something wrong. So those are just some ways to kind of check yourself.